Today we're taking a look at finding the area of a triangle. If you remember from your days in geometry class, to find the area of a circle, you took 1/2 of the base times the height. In the example we have here, the base is going to be 8. The height we need to find. So if we drop in an altitude perpendicular to our base, we find our height would be that side. Now to find the value of that height, we're going to take advantage of the right triangle we have here using the 30 degrees. The height is going to be the opposite side. The 6 is going to be the hypotenuse in that right triangle. So using the opposite and the hypotenuse, we're going to want to pick the sine. So the sine of 30 degrees is going to equal the opposite side, the hypotenuse, or the h, the height, over the hypotenuse, which in this case is 6. So if we solve for h by cross multiplying, we're going to get h is 6 times the sine of 30 degrees. We can then put that in for the h over here. Then either using a calculator, unit circle, or your brains, we can quickly deduce that the sine of 30 degrees is going to be 1/2. So if we multiply the 1/2, the 8, the 6, and the 1/2, find the area of this triangle is going to be 12. And of course, area is always in units squared. Now somebody very wisely noted, every time you need to calculate the height in these cases, we're going to be using the sine to do that. So a general formula for the area of a triangle, if you have two sides and the angle included in between the two sides, known as the side angle side case, is A equals 1/2 AB times the sine of, in this case they used gamma, to indicate the area, or the angle, between the two sides. So for the next problem, if we take a look, we can basically feed the numbers into the equation. We got the 1/2. The two sides are the 8 and the 12. Sorry about the interruption. The angle between the two sides is 20 degrees. So in this case, we're going to do the sine of 20 degrees. We plug this into your calculator, crunch it out, and we should get something in the neighborhood of 16.417 square units. The next one is also very much straightforward because the 100 is between the two sides. So we can use the 1/2, the 4 and the 3 for the sides, and then do the side of 100 degrees. Plug this in on the calculator, and we find out that A is approximately 5.909 square units. Now the next case gives us a little more difficulty. In this case, they give us two angles and only one side. Now we have a couple options. We can either find the missing side down here, in which case it'll be the 4, the x, and the included angle would be the 20 degrees. Or if we find the other side, we would use the 4, the y, and the 85 degrees. Either will work. Now, in either case, to find the missing side, we're going to have to use the law of sines. So, since the 4 is over here, and we do not have the angle opposite the 4, we need to calculate that first. So remembering that interior angles of a triangle add up to 180, if we subtract the 20 and the 85 from 180, we should quickly come to the conclusion that the missing angle is 75 degrees. If you want to double check my math, that should work. Now, the law of sines, like I said, let's do the x in this case. Says that we do the sine of the angle, in this case 75 degrees, over the side that it's across from, the 4, and that'll be equal to the sine of 85 degrees over the x. If we cross multiply, we get x times the sine of 75 degrees is going to equal 4 times the sine of 85 degrees, which therefore means x is equal to 4 times the sine of 85 degrees divided by the sine of 75 degrees. Plug this in on the calculator, and hopefully everybody will agree that x should be somewhere in the neighborhood of 4.125 units. At this point, now to find the area, we're going to use the 4.125, the 4 for that side, and now the angle in between them is the 20 degrees, so the sine of 20 degrees. Once again, plugging it in on the calculator, we should find that the area is somewhere in the neighborhood of 8.25 square units. Now, if all we have are the 3 sides of the triangle and we don't have any angles, we need to use something that's known as Heron's formula. Heron's formula is given here, A equals the square root of, and then we got S times S minus A times S minus B times S minus C. S is the semi-perimeter, which is calculated by adding the 3 sides, A plus B plus C, and dividing by 2. If we look at the first example here, the sides are 4, 5, and 7 meters. So the first thing we're going to want to do is find the S. So we're going to add the 4 plus 5 plus 7 and divide by 2. If we do the math, hopefully we should be coming up with 8 for the S. Then to calculate the area, we got 8, and then we're going to do 8 minus each side. So 8 minus the 4, 8 minus the 5, 8 minus the 7. Up to you whether you want to put that in directly, or you can do 8, or actually do the subtractions. So we got 4, 3, and 1. Either way, we plug this in on the calculator, take the square root, and in this case, the area is calculated to be approximately 9.798 meters squared. For our other example in this case, we got sides of 6, 7, and 8. So to find the semi-perimeter of the S, we're going to add the 6, the 7, and the 8, and divide all that by 2. For that, we should get 10.5. It's therefore means to find the area. It's going to be the 10.5. And then we got to do the 10.5 minus the 6, the 10.5 minus the 7, and the 10.5 minus the 8. Once again, you can either punch it in directly or you can subtract them. So the 10.5 minus the 6 would be 4.5, 10.5 minus the 7 would be 3.5, and 10.8 minus, or 10.5 minus the 8 would be 2.5. Plug it in on the calculator, take the square root, and hopefully you should be getting somewhere in the neighborhood of 20.333, and this would be square inches. Hope this helps as far as finding the area of the triangles.